Welcome to Homework Lib.
In the first part of this problem, we are going to calculate the angular frequency and the time period of the oscillations. For angular frequency, we write omega is equals to 1 divided by square root of LC, where this L is the inductance and C is the capacitance. So by inserting values into this equation, we can write 1 divided by square root of L, which is equals to 1.50 Henry, into C, which is equals to 6.00 multiplied by 10 raised power minus 5 farad. So this will give us the value for this omega as 105 radian per second. So this is the answer to the first part of this problem. Now for time period, we can write t is equals to 2 pi radians divided by omega. So this can be written as 2 multiplied by 3.14 radians divided by omega, which is equals to 105 radians. So this will give us the value for this time period t as t is equals to 0.060 seconds. So this is the time period. Now in second part of this problem, we are going to calculate the initial charge on the capacitor plates. That is what we call Q naught. So for this quantity, we can write the equation Q naught is equals to C E, where this is the potential difference between the plates. Now by inserting values into this equation, we can write Q naught is equals to into 6.00 multiplied by 10 raised power minus 5 farad into E, which is equals to 12.0 volt. So this will give us the value for this Q naught as Q naught is equals to 7.20 multiplied by 10 raised power minus 4 coulomb. So this is the charge on the plate. Now in part C of this problem, we are going to calculate the energy stored in the capacitor initially, that is UC. Let's write the equation for this energy in capacitor. UC is equals to 1 divided by 2 C E square. So by inserting values into this equation, we can write 1 divided by 2 into C, which is the value of 6.00 multiplied by 10 raised power minus 5 farad into 12.0 volt whole square. So this will give us the value for this UC as UC is equals to 4.32 multiplied by 10 raised power minus 3 joule. So this can be written as 4.32 millijoule. So this is the energy stored in the capacitor, this one. In part D of this problem, we are going to calculate the charge on the plates of the capacitor at the given instant of the time, that is small q. So the charge on the plate at any time is written as small q is equals to q naught cosine of omega t plus phi. As at t equals to 0, this q becomes capital Q naught. At that point, we can write this phi is equals to 0. So this equation becomes small q is equals to capital Q naught cosine of omega t. So by inserting values into this equation, we can write this small q is equals to capital Q, which has the value of 7.20 multiplied by 10 raised power minus 4 coulomb into cosine of omega, which is equals to 105.4 radians per second into t, which is equals to 0.0230 second. So this will give us the value for this charge on the plates of capacitor as q is equals to minus 5.42 multiplied by 10 raised power minus 4 coulomb. This negative sign shows that the capacitor is discharged completely which has positive charges initially, and now the plate has negative charges. In part E of this problem, we are going to calculate the current in the inductor at the given instant of time, that is I. We can write the equation for this current as I is equals to minus Q naught omega. Then here we have sine of omega t plus phi. So we know that this phi is 0 at t is equals to 0 and so on. So we can write this equation as I is equals to minus Q naught omega sine omega t. Now let's write the values into this equation. We can write it as I is equals to minus into 7.20 multiplied by 10 raised power minus 4 coulomb into omega, which is the value of 105.4 radians per second, and then we have sine of omega t, which is equals to 105.4 radians per second into time, which is equals to 0.0230 seconds. So this will give us the value for this I as I is equals to 0.050 ampere. So this is the current. In part E of this problem, if F of this problem, part F of this problem, we are going to calculate the energy stored in the capacitor and inductor at the given instant of time, that is UC and UL. The energy stored in the capacitor at the given instant of time is written as UC is equals to 1 divided by 2 small q square divided by C. So this can be written as 1 divided by 2 into small q, which is equals to minus 5.42 multiplied by 10 raised power minus 4 coulomb whole square divided by C, which is equals to 6.00 multiplied by 10 raised power minus 5 farad. So this will give us the value for this UC as UC is equals to 2.45 multiplied by 10 raised power minus 3 joules. Now let's write the formula for this energy stored in the inductor, that is UL. So UL can be written as UL is equals to 1 divided by 2 Li square. Now let's write the values into this equation. UL is equals to 1 divided by 2 into L, which has the value of 1.50 Henry, into I, which is equals to 0.050 ampere whole square. So this is equals to 1.87 multiplied by 10 raised power minus 3 joule. So this is the answer. End of the question. Thank you.